So today you're learning how to factor difference of squares. So to start, we're just gonna FOIL the top part here to multiply these binomials together. So for the first one, so you'll do x times x first. We're just trying to see what's happening so we can relate it to what you're learning today. So that'd be x squared to start. And then you can distribute the x to the -3. So then it'd be minus 3x next. And then you can distribute your 3 to the positive x. So that'll give you plus 3x next. And then you can do your 3 times the -3, so that'd be -9. And then remember, you'll combine your like terms if you have any there. So you can combine your x's in the middle. So you can do -3x plus 3x, so that'll be 0. So you'll just have x squared minus 9 for this answer then. And then for the next one here, so you're doing the same thing. So you multiply 2x by 2x first. So that'll give you 4x squared. Then you can distribute the 2x to the -4. So that'd be minus 8x next. Then you can multiply the 4 by the 2x, that'd be plus 8x. And then you'll have the positive 4 times the -4. So that'd be -16 at the end then. And then for your like terms here, you can combine the -8x plus 8x. So that'd be 0x. So you'll have 4x squared minus 16 then. And then for this one here, so 5x times 5x first, so that'd be 25x squared. So you'll have 25x squared to start. And then you can distribute the 5x to the -7. So minus 35x next. And then 7 times your 5x, so that'd be plus 35x next. And then lastly, you'll do 7 times the -7. So that'd be -49. And then you'll combine the -35x and the 35x here. So they'll cancel. So you'll have 25x squared minus 49. So if you notice with these, so your middle term's canceling each time. And if you look at each of the binomials to start, they're the same except for one you have a plus and one has a minus here. So pretty much, so as long as this happens, your middle terms will always cancel here. So today you're learning how to do that, but the opposite. So you're factoring. So you'll be factoring the difference of squares. So pretty much you'll factor what you start with. So you can do this as long as both of your terms are perfect squares and you're subtracting. So which means for this one here, a squared minus b squared. So you can do this as long as both of these are perfect squares. So a squared is a perfect square because a times a will give you a squared. And then b squared is a perfect square because b times b or b squared will give you that. So that one of these, will be a plus b and one will be a minus b. You'll have one of each there. And you can always FOIL this back out like we did up there if you want to make sure that you get the same thing because you'll have a squared and then minus an ab and then plus an ab minus b squared. So your two middle terms will cancel for that one. And then for the next one here, so x squared is a perfect square because you would square x to get that. And then 16 is a perfect square because that'd be 4 squared would give you the 16. So since they're subtracting, so you'll have one of each sign there. So for these here, so I would first check to make sure, so even if your terms are perfect squares, I would always check to make sure there's not a GCF you can factor out first. So for this first one here, you have x squared minus 49. So there's nothing you can factor out from both of these. So you can just follow these steps here. So you can check to make sure both of these are perfect squares. So you're checking to make sure what x squared is a perfect square and 49 is. So they both will be. So that'd be a yes to start them. And then for it to be a difference of squares, so like it says, it's a difference of squares, so they have to be subtracting. And they are subtracting there. And then you're finding the square root of each of those terms next. So the square root of x is x, and then the square root of 49 would be 7. And then when you write it out, so one's going to have a plus and one's going to have a minus there. It doesn't really matter what comes first. You'll just need one of each sign. So yes, this would be your factored answer with the difference of squares there. And then for the next one, so there's not a GCF you can factor out from 4x squared minus 81. So you can just check and make sure they're both perfect squares to start. So 4x squared, so that'd be a perfect square, because if you square 2x, you'll get the 4x squared. And then 81, that'd be 9 squared. So these both would be perfect squares then. And then you're making sure it's subtraction, which it is. So that's a yes. And then it's asking the square root of each term. So this, like I said, the square root of 4x squared will be 2x. And the square root of the 81 will be 9. And then you'll have one at the plus and then one at the minus. So that'd be your factored form there. And then for the next one here, so 16x squared minus 121. So the only thing that goes into 121 would be 11 in itself. So, and neither of those go into 16. So there's nothing you can factor out first there. So for this one, you can just check and make sure both of these are perfect squares and they're subtracting here. So both these are perfect squares. So the square root of 16x squared would be 4x and the square root of the 121 would be 11. So you now have 4x plus 11 and then 4x minus 11 because you'll need one of each there. And then for the next one here, so 25x squared and 144y to the fourth. So the only thing that goes into 25 would be 5 and then 25. And so 5 wouldn't go to 144 and then 25 wouldn't go into that either. So you can just check and make sure they're perfect squares and they are subtracting here like you wanted. So the square root of 25x squared, so that'd be 5x, and the square root of the 144y to the fourth would be 12y squared. So you'll have 5x plus 12y squared, and then 5x plus, or sorry, minus 12y squared. And then for the next one here, so if I was supposed to cover this up, but anyway, for this one here, so you may notice, so these aren't perfect squares here because nothing times itself will give you 2x to the fifth, and then the same thing for the second term there, the 98x cubed. So they're not perfect squares here. So you can check to see if there's a GCF you can factor out here. So for 2 and then the 98, so your number GCF will be 2 here. And then for x, you have x to the fifth and then x to the third. The most x's you could take out from both would be x cubed to start. So you can factor out a 2x cubed from both of those. So this is what you'll have. And then you'll figure out 2x cubed times y will give you the 2x to the fifth. So that'd be x squared. And then 2x cubed times y will give you the negative 98x cubed. So that'd be minus 49 then. And then you can just check to make sure these are both perfect squares, and then they are subtracting there. So the square root of the x squared will be x, and then the square root of the 49 will be 7. So you'll have x plus 7, and then x minus 7 with the 2x cubed outside. And then for your next one here, so 100x squared minus 27y to the fourth. So I would check to make sure, like, if there's a GCF you can factor out. So 27 be the biggest factor here, 27, and that wouldn't go into your 100. And then the other factors of 27 are 9, which wouldn't go into the 100, and then 3 wouldn't go into the 100 either. And you can't take any variables from both. So you can check to make sure these are both perfect squares. So 100x squared, so that would be a perfect square because that'd be 10x. But 27, y to the fourth is a perfect square, but 27 isn't here. So nothing times itself will give you the 27. So this will be prime for this one there. So if you forget the shortcut way here, so you can always go back to doing this the long way if you want. So I would rewrite this. So you can write this as a trinomial here because you have 16x squared minus 9. So if you're to rewrite it as a trinomial with 3 terms there, so you have 0 x's here because you don't have any, because pretty much your x's canceled. You don't have anything in the middle. So if you were to write it out the long way, it would look something like this. Because your 16x squared is still there, and then your minus 9's there, and then you have your plus 0x because you don't have any x's, just regular old x's here. So you could write it out the long way here, and then you could do a times c. So you could do negative 9 times 16. So if you multiply those, you'll get negative 144. So here you would need factors of negative 144 that would add to give you the 0. So for this one, you'd have to have a positive and a negative, since you're trying to multiply to get a negative 144. So this would be negative 12 and positive 12 that you'd have to use then, because they would add to give you the 0. And then you could sub both of those in together next. So it'd be 16x squared minus 12x plus the 12x and then minus 9. And then remember from here, you can group your first two terms and then your last two terms. So you have 16x squared minus 12x. So your numbered GCF for those two terms would be 4x. And then you're figuring out 4x times what? Will give you the 16x squared. So that'd be 4x again. And then 4x times what will give you the negative 12x. So that'll be negative 3 next. And then your GCF for your last two terms, you have plus 12x minus 9. Remember, both sets of parentheses have to match here. So for this one, your number GCF will be 3. So you can write plus 3. And then you're figuring out 3 times what will give you the 12x? That'd be 4x. And then 3 times negative 3 will give you the negative 9. And then also, because you know your 4x minus 3 has to match since that's in both parentheses there. So then you can write this the short way. So you'll have 4x plus 3 and then 4x minus 3, which is the same thing you would have there if you use your rules or factor in the difference of squares then. So for number 8 here, so 49x squared plus 64y squared. So for this one, there's not a GCF you can factor out from both to start. So you can just move on to the other steps there. So I would check to make sure both of these are perfect squares. So 49x squared, so that would be 7x squared. We'll give you the 49x squared there. And then 64y squared is a perfect square because that'd be 8y. But then this sign here, because in order to factor it as a difference of squares, this would have to be a minus, since in the name it says it, since it has to be a difference. So if you try out different things here, so if you have both the same sign here, this would multiply to a positive in the end. But if you write it out like this, then your middle term wouldn't cancel. You'd have to combine them there, since they wouldn't have opposite signs. It wouldn't actually cancel. So if they're both positive, that wouldn't work there. And if they're both negative here, so your signs, the sign on the 64y squared, and you multiply the negative 8 and the negative 8y here would be right, but your middle term still wouldn't cancel here. So having both negatives wouldn't work there either. And then for this one here, so for this one, your middle term will cancel if you have one of each sign, but when you multiply the positive 8y times the negative 8y here, they wouldn't give you a positive 64 like you're supposed to multiply to get there. You would get a negative instead. So since none of those work there, this would be prime. Because pretty much in order for this to work here, you have to be subtracting. Or at least one of them has to be a negative. If it was like a negative 49x squared, that could work. You could always reorder if you wanted to help. And then for this last one here, so I would check to make sure there's not a GCF to start. So the only numbers that would go into the 49s would be 49, which wouldn't go into 225, and then also 7 is the only other factor of 49. So 7 doesn't go into 225. So there's nothing you can factor out first for a GCF. So I just check to make sure these are both perfect squares, and then they are subtracting here, so that's good. So you can go and write your parentheses, because the square root of 225x squared would be 15x, and then the square root of the 49y squared would be 7y. And then you'll have 1 plus and 1 minus there then. So that'd be your answer then. Okay, so that's the last one there. There is a Google form that you're going to work, not a Google form, there's a Google Doc that you're going to work on today that's more practice of this here. So just make sure that you're checking first for a GCF to factor out. Just because both your terms are perfect squares doesn't mean you can just skip straight to the next part. I would always check for a GCF first, because sometimes they may be perfect squares already, but you need to factor everything out that you can. So you're going to work through that and let me know if you get stuck, and then I'll also check your answers and respond.